Tonight, I am sanding the for all the hands that I'm making for other people and doing all the fitment to the medials. And I figured I would do a live so I could have a little company while I'm doing it. Hopefully, people start popping in. Oh, so close. Well. Oh, it looks like I broke a spring. That sucks. Oh, I need a spring. One spring. So tonight I am sanding the distals. A pile of distals. What up, David Lee? You have not responded to my email. So how's it going, man? Let me see what else is on the network right now. You know what? I'll move to a different part of the shop and see if I have better reception there. Yeah, I haven't, I got the one reply email from you, but I haven't, but then I asked some questions and I haven't seen anything past that. It was, I was still in Detroit at the time. Okay, we're gonna go to the front of the shop. Maybe I have better internet up there. I know I'll have a flatter table. Oh my gosh. All right, is the internet looking better now? Okay, I'll go grab a chair from the new and improved laser room. This is my new laser room. Ooh, and a fiber laser. All right, I'll grab this chair. Should probably grab a medial too while I'm there. And I have 4 printers going right now, all printing out hand parts and stuff. Oh, there's a spring. I broke the spring that goes to my ring finger, so I'll replace that real quick. All right. All right. Now let's set up a camera. Need probably like a 1, 2, 3 block. Which loaner 3D printer? Yes, I do want your address and phone number for faster communications. All right. All right. Oh no, all the printers that are sent to me become mine. I don't send back any of the equipment that gets sent here. That's part of the deal. No. Hey David, how wide is your residual limb? By the pictures, it looks to be about 4 inches wide. Okay, pretty close. So I'm using 3M77 to stick the sandpaper down tonight. I've got about 100 distals to sand to get them to fit into the medials. I think I need a different can of glue. This one isn't working so good. There are lots of things that I'm working on the hand. Working on a new lock mechanism. I'm working on a new way of doing the forearms. Sure. Tonight I am sanding to, what am I doing? Tonight I am sanding the distals from all of the PCB-way stuff that I ordered a couple months ago. Because they come sized pretty close, but they aren't really right. I mean, they're close, but they're not. It's like these, they have to fit into the medial. So I went and I just did a couple passes with the file to just take off the rough spots on the sides of it, and then I flat file the distals until they just fit in between the ears. And I use the same one of these for all of them, and that becomes the master. So then you're just, you're filing them all to fit the master. The trick is to not get too much pressure to where you're not taking off a bunch of material, but you need to take enough that you're getting the job done. And then also, you got to keep it all square. This is some of that work that it was supposed to be for the end users, but I'm just trying to get it to where everybody's going to be a little more successful. Because I need to take off awesome. That is awesome to hear. Okay, so, it just has to just fit. So wet sanding wouldn't remove enough material fast enough. And also, I'm using 220 grit. I've done this many. I have about 80 more to do. So David, your hand is going to be a forefinger device, very similar to what mine is. I'm also 4 inches wide, out. Well, 4 and change. So that's awesome. And off of your pictures, it looked like you had full-length metacarpals. Like when they closed you up, they didn't take anything off of the metacarpals for a length. Right? Oh, still too tight. Sweet. And then after this, then I will drill all the holes. And then I actually have to machine this little slot. I have to open it up for these. So these parts I had gang printed, and they slide into that little slot there. So after I drill the holes on these, then I run an end mill and just touch both sides of that, and that, smooths everything up. Yep. Perfect. Yeah, no, I pretty well picked up on what you had going anatomy-wise, which, that should be awesome. I mean, it should work really good. I'm working on redesigning the splay mechanism. Oh, I just ripped my sandpaper. That sucks. So, in case you didn't know, I went to a rapid TCT last week with Creality. It was pretty good. I did a presentation at their 11th anniversary party. I think it was pretty well received. Um, everybody that went there that knows me said it went pretty well. So that's cool. That was my first show of the year. I think I'm going to be going to Denver Rep Rap, but I haven't got my ticket to go yet. Supposed to be going with Polymaker, but we only just kind of talked about it. And if I end up going with them, that'll be a first working with them. I haven't done a bunch with them yet. They have some material that they're supposed to be sending me for the sockets that's supposed to be really awesome for doing like an IDEX print where I'm doing the hard and the soft. To where I'm printing on the frame portions of it. No, because that is actually a real live licensed category, and you can get in trouble if you say that you are and you don't have the certificate. Then you have to carry errors and omission, insurance, and at least in Oregon, you have to work for a licensed and approved clinic for like 7 years after you get your certificate. Awesome. Well, thank you. Thank you, Blake Anderson. I appreciate that. I appreciate it anytime someone goes and shares my videos and gets my project out there. Yes, that would be a bad deal. I mean, I'm already kind of skirting the edges of red tape and getting in trouble. Last thing I want to do is call myself a prosthetist or a clinician, and then that's just inviting an audit. That's just inviting to get in trouble. Of course, it'll be interesting if I end up getting in trouble because of how the 3D printed guns are now looked at. Because a couple weeks ago, the Supreme Court ruled that components of a 3D printed firearm are considered the firearm itself, and it doesn't have to be assembled or anything. And that isn't a very big stretch to components of a prosthetic are considered a prosthetic. So it'll be interesting to see how that ends up going. Awesome, thank you. I appreciate that. Tonight I am sanding distals from all that stuff that I got from PCBWay. And I'm so glad that I ordered all those parts when I did. I mean, my gosh, if I was doing that now, the tariff would be absolutely terrible. I mean, don't get me wrong, I already paid $1,600 in tariffs to get these parts in the country. But had I waited until now, it would have ended up being like $4,000 more in tariffs. And I think, manufactured components is now at like 164% tariff. So, my box of parts was $5,000. So this would be, an additional like 6,500. Thank you, Rex. Oh, yeah? David, when was the last time you were getting looked at in a clinic? Are you still working with a prosthetist, or are you outside of that now? Whoop. Ripped my paper again. Oh, that's cool. Have you talked to them about, have you mentioned that you're thinking about working with me for a device? No, there honestly there really isn't. And that's really what drove me to be doing what I'm doing now. Um, just because what was available, it it was so far from meeting my needs. I mean, it wasn't, my gosh, it wasn't even close. I didn't get as far into the weeds as you did. I only had one device made for me. I had an Oser iDigits Quantum made, and it was absolutely terrible. It was so slow. It was, well, I mean, it's 1 second to open, 1 second to close, and it runs out of batteries, and super fragile. I mean, I think I broke mine, broke it the first time within a week of getting home with it. I ended up snapping the string that drives the ring finger. I was basically doing nothing with it, and it just snapped. Right? No, totally. Totally. I don't know. Mine was, so did you go to the Oser Institute in Dublin, Ohio to get fit for yours? Oh, okay. So when I had mine done, um, everything had to be done at the Oser Institute. So there's a Wendy's that's, so what they do is they fly out your your clinician, you and your clinician, out to Ohio, and then your clinician was supposed to have cast your residual limb, sent that in, so they dry it and all that by the time you get there. And then, then they make up a test socket off of that. And then you and your clinician go and position the fingers. And then in the 3 or 4 days that you're there, they go and they put everything together for you. And then like the next to last day that you're there, you get to take it out in the wild, still kind of in its test form. And it was absolutely the worst. I went around the corner to the Wendy's, and I'm still figuring out how much contraction I need to do in order to hold the fingers, not close them, not open them, but just to hold them. And we were still adjusting the thresholds on the little iPad thing, and it was everything that I could do not to just squish my drink cup at Wendy's. And it was comical how bad it was. I mean, it was just terrible. But I tell you, that place was kind of so much of a mill. When I went, I had been using a device that I made, and they were kind of like, well, why are you here? It looks like you already have a pretty good device. And I'm like, well, I'd like it if you guys consider this kind of a job interview, really. And the clinicians were super into that. And my clinician was into it. But the guy that was actually running the clinic, he was not so much. So then my prosthetist, he ended up getting me in touch with Hugh Gill, who was director of R&D in Scotland for Open Bionics, or not Open Bionics, Touch Bionics. And then I interviewed with him a couple times. I thought that was actually going to go somewhere, and then COVID happened, and then the world shut down. But, had I done that, I probably wouldn't become YouTube famous. I probably wouldn't be where I am now, project-wise. And I'm still working on a bunch of different aspects of it. Like right now, I have 3 different things that I'm working on for it. I'm working on the splay mechanism, trying to get rid of this width. Don't really like this, and this goes down into your palm just a little bit more than what I super like. But I like the motion of it. It's a nice even motion. But I just got to change how the drive is. And then I'm working on a different latching mechanism for the ring and pinky finger. And then a different forearm piece. Because I want to tie it to basically the elbow, to when you go from, pronate to supinate, that it isn't biting into your radius, into your ulna bone, this bone on your wrist. What I'm having right now is, if my forearm is a little bit swollen, then the forearm cuff ends up, grabbing too much on my forearm, and then as I rotate it, then it bites onto the head of the ulna bone. So, but if I make it go all the way to the elbow and just have it rotate around, then I shouldn't have that as an issue so much. I mean, it's still super, super early right now. Um, Probably next week or so, I'll be making a prototype of that. Uh, right now I'm still trying to get caught up on my real work so I can get back onto videos. I've got 3 videos that I'm editing right now. And we'll see. I've got to get back into doing videos. The problem is YouTube hasn't been treating me exceptionally nice lately. And I've had, a bunch of real work come in. I manufacture a lot of parts for a bunch of gold miners. And everybody's getting ready to go up to Nome, Alaska right now. So, it's easier to go turn dials and make parts than it is to go and write, shoot, and edit videos that may or may not do good. Just a little bit more. I think this batch of fingers and stuff I'm going to send out to Cerakote and have them coat them up. Oh, David, how do you feel about black, orange, and gray for the colors? So close. Yep. So I've still got 4. Let's go by 5s. 2, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 4, 5. 4, 5, and 4. So 5, 10, 15, 20, 25, 30, 4. So I still got 34 more distals to go. And then we'll hop over to the milling machine and drill all the holes. Whoop. Close. Boy, the chat is really quiet tonight. Is it working, or is technology failing me? Okay, I'm gonna grab my other phone real quick. Just so I can see how and if the live is looking like crap or working. All right, let me get onto YouTube real quick. All right. All right. Oh, that's so odd. Sorry. Oh, that's so odd. Sorry. Oh, that's so odd. My text has frozen on the phone that's. And yes, Shane, you are watching a live of me sanding parts. Yeah, so the chat froze on my other phone. I just had one of my friends text me going, "Am I really watching a live of you sand parts?" Yes. Yes, you are watching a live of me sanding parts. That way, you can actually see the love and attention that I'm putting into each one of these devices. So close. Huh. So close. I am down to like 32 distals left. And then we can start drilling the holes. Too tight. Thanks, I appreciate that. Sometimes it gets super frustrating. It just doesn't feel like the project is going as fast as what it should. It feels like honestly, it feels like I'm watching a Winter Garden series. The guy that's making the musical instrument that's played by the ball bearings. It feels like I'm caught in that type of scenario where I'm just always working on it and never finishing anything. We need to go a little bit more. Yeah, that's supposed to be the version that you can use for non-professional work, the SolidWorks for makers. You're supposed to be able to use it as long as you don't make more than, I think, like $600 in a year on it. I don't know. I'm an AutoCAD person. I never really got into how the flow of SolidWorks was. I started with AutoCAD 10 back in 1993. So, that just means I'm old. So 5, 3, 5, 3, 5, 2, 4, 5, 5, 10, 15, 20, 25, 28. 28 left to go. Right? No, that sucked, because that was a permanent standalone license. And the worst part about it was, because I was doing the PDSU version of it, I had Inventor, which, is different than, Fusion 360 Inventor, because I had finite element analysis. So I had real life FEA, I had Mudbox, I had, it was a great product. But right after that, I think it was 2015, they went to a subscription basis only. And, I've just seen too many issues with that. Like, I have a customer that their plant is down in Roseville, and he'll come up, to the shop here, and he can't log into the system if he doesn't have internet here. So he can't open up drawings that are on his laptop because he can't log into AutoCAD and check to make sure that he has a valid license. And I just hate the idea of being held hostage and locked out of, your own drawings, because, say if Autodesk servers are down, which they are sometimes, or, they're super busy or whatever, then you can't access the drawings that are on your laptop, not even, doing it off of a cloud-based thing. And, that just kills me. Yeah, so, Mr. Niner, yes, I started this for me, because there was nothing in the partial hand prosthetics that was durable enough or fast enough to be usable for me with what I do. And, you know, then COVID happened and I accidentally became YouTube famous. And then it's kind of just this thing of, you know, well, if I can start making them for other people, then that's awesome. So yeah, no, it was all on accident. And I mean, you know, if you would have told me, you know, if 10 years ago you would have said, hey, in 2025 you're going to be making YouTube videos and doing that thing, I would have laughed you out of the shop. What up, Madrid? There we go. 5, 10, 15, 20, 25 left. And I need a new piece of sandpaper. Oh, that's awesome. Okay. Oh my gosh, it's like a potato there. No, I have it 3M77. I have it 3M77 down onto my welding table. Awesome, thank you. I appreciate the long time watching. So last week I was in Detroit at Rapid TCT, which was awesome. And I got a contact for Bamboo Labs, you know, to see if they wanted to start sending me printers and stuff. And, oh, totally. And I got told that my metrics weren't quite in line with what they're looking for their demographic. All right, I'm going to get another piece of sandpaper. New sandpaper. It isn't as durable sandpaper as what they advertise. You can see all the holes. I don't know. I think it was, I'm not making as many videos right now as what they'd like to see. I'm not getting the views that they want to see. I don't know. She didn't really give me a definitive thing, but I explained to her, that during the winter, I work with the Super Bowl, that I do interior state and project managing for the Super Bowl, and that's what, if I do that job, then I can afford to make YouTube videos and do less paying work. So the tediousness of this is just to get the fit right. Right now, so like on the distals, there's no real good way of grabbing them to go stick them in the milling machine. I mean, you only have this, it's a 1/4 of an inch by 3/16 of an inch tang, and there's no real good way of grabbing that on the milling machine and then taking a cleanup pass. But like on the proximal ones at least, right now I have vice jaws that I'm printing out that I'll be able to just clip those into the vice jaws and have them automatically index. So I'll be able to do cleanup passes on those. But like on the medials, I think the medial is going to be the same way. I mean, there's no real good way of grabbing a hold of this piece, to where you can clean up this inner thing. I think these are going to have to be a hand file type thing as well. And that's after you take off this little spreader bar. Okay, so what they do have, yeah, no, I have a couple of CNC milling machines. Let's see. There's one of them. And then that's another one of the CNC milling machines. And that's one of them. And then there's another one over there. And there's another one behind this milling machine. God, that's a potato. Yeah, no, I have a lot of equipment in the shop. I have an awful lot of gravity. Thanks, I will. I will try to keep it up as long as I can. So close. I do. I have probably, let's see, I probably have 200,000 pounds of gravity here. Right? Well, it's just because, I don't have any real good way of holding on to these pieces in order to get them to fit right into the medial. What do you mean, Terminator fingers? No, this is just to get everything to where it fits right. The next is to drill the holes and then put the pins in. And at some point in time, I'll send them off to get Cerakoted. Cerakote wants to do, has been wanting to do a thing with me for a long time. And this is the batch of, this is going to be the batch of stuff. No. So the problem with, I mean, first off, it's a movie. But in order to do motor drive fingers like that, you have one of three things. You either have to scale it up size-wise, to where you can make bigger motors, or if you're going to do motors that are 1/2 inch in diameter, then you have to up the amperage from the power supply and the control. But then, you have to be carrying around larger batteries. And they aren't going to last very long because, now you're drawing all kinds of, amps and current. Or you have to move the motors higher up in your arm to where then you can go with larger motors. So no, I'm going to, being mechanical, they don't run out of batteries. They don't really care if they get dirty. They don't, there's just a bunch of benefits going with the mechanical for the drive. Now, I may eventually go back to doing Myo or EEG. Awesome. Be safe at the bar. So I may go back to doing Myo or EEG for direct control of the fingers, but for driving them, for the actual motion of the fingers, I think for me, it's always going to be mechanical. Just because of the reliability. When you have to use it, every day, all day, reliability is like the number one, it's the number one thing that you're looking for. And as soon as you start introducing electronics and stuff, man, the reliability just, yeah, but like with those tiny motors, they have no torque. So then you're trading speed for power. And like with my OSER digits, it takes 1 second for the fingers to open and close, which, doesn't sound like a lot, until you're until you're sitting there waiting for it to open or close. And then you're like, oh my gosh, this is taking forever. You know? Yeah, I mean, right now, I mean, I tried doing the electric and the hybrid systems a couple years ago, and they were always just too gadgety for me. There was nothing that was, super stable that, you'd look at and you go, oh my gosh, that's it. And part of that is just, the amount of cycles that it has to do. Because, even when it's doing nothing, the microprocessor is still doing cycles trying to determine, oh my gosh, was that a muscle contraction? Did you mean to contract your finger? And that eats up a pile of processing time. I mean, I was using a Raspberry Pi Zero at the time, or an ESP32. I used those for quite a while, too. And, even doing a bunch of learning for it, this is what the muscle pattern looks like for it contracting or that type of thing. Then the microprocessor has to go through all of that learning in order to, determine what it's really trying to do. And if you have your language model too large, it just makes it to where it ends up making everything to where it just slows down too much to be usable. You can have it be super accurate, but then it's like, it's super slow because it's trying to make sure that it's super accurate. All right, down to 16. Well, that one still just feels kind of grabby. On a water-powered engine. Like HHO water-powered, or what are you talking about? I mean, I imagine that you're talking about HHO. right? It's not ASMR on this side of the on this side of the camera. Yeah, so I don't know. I mean, I have a couple people that I've been on and off doing HHO and resonance to break it apart. You know, piezo-driven resonance in order to break the water apart and then recombine it in an ICE format. So, I mean, it does have merit. It's just, you know, it takes an awful lot of energy in order to break the water into its hydrogen and oxygen components. You know, the burning it to get back to water is okay. So for Icky, so right now I'm using TPU for the cores, for the core part that goes, well, it's the part that locks onto this part of the distal. So straight 95A TPU there. And then for the top of the finger, this blue section, that's ColorFab. That's ColorFab TPU. And that's printed at, what is it, 225. So it's got a little bit of squish to it. And then for the palm side, if I'm wanting to have, if I'm making super squishy compliant fingertips, then I'm using Recreus Filaflex. And that's a really good squishy filament. If I'm just trying to make ones that are like average durability, then I use just another ColorFab and print it at 255. And that seems to work pretty good. You know, depending upon what you're doing, they'll last, you know, I mean, it all depends on what you're doing as to how long the fingertips last. You know, if I'm doing a lot of, you know, sheet metal and metal work, then I'm better off running these fingertips. These are still printed out of the ColorFab TPU, but they're all pretty hard. It's a pretty dense print. So, you know, there's still a little bit, I don't know, and I'm still working on a couple little designs. Like on the Recreus stuff, you know, the Recreus ones, I'm doing different patterns on the fingerprint side of things, just to get a little more compliance to where they're squishy, but they don't rip. And like the main issue with the Recreus stuff is you have to have that stuff so dry. I mean, and it absorbs moisture just immediately. So as soon as you take it out of the dryer, you know, as soon as you take it out of the dryer, it's already absorbing moisture. So, you know, you print it, you cook it, you print it, you cook it. But Recreus also makes a filament that's conductive. So you can use that for if you're going to be doing touchscreen, you know, if you need it for touchscreen on your cell phone. And that's kind of where I am on fingertips. Down to 10. Down to 10 parts. Okay, so one of my other forearm grips, the one that I was wearing for Rapid, that one has a wristwatch on it. And I do like the wristwatch ones the best. So I really do like having the watch accessory on there. The problem with it is that forearm cuff just tears my wrist up. I need to rework it a little bit. And, you know, between real work and, you know, and just the drive to do it, I haven't wanted to spend, you know, the day, 2 days in order to make a new forearm cuff that, you know, I can attach a watch to. But yes, no, I'm still doing the wristwatch on the forearm cuffs. You know, someday I hope to have a Rolex rocking around on that. Yeah, well, and then also, I don't know if you've come into this as an experience. You know, if you end up, you know, drawing and redrawing your filament a bunch, I found that it gets super, super brittle. And, you know, it's almost better to just deal with the stringing that you end up getting and leave it somewhere around, you know, between 25 and, you know, even up to 40% humidity. You know, I've had a couple instances to where it's just like I overcooked. You know, I got it to where it was like 15% humidity, and then it became just way too brittle. You know, and it was always breaking off in like the AMSs or CFSs or, you know, whatever machine you're running. You know, so you got to give it a couple days to rehydrate before you can use it. Boy, it's so weird. It looks like you have different materials in this mag aluminum. You like have this line. Okay. So I had PCBWay print the fingers out of mag aluminum or mag silicon aluminum. I've been really happy with them, you know, and the price is awesome. Well, I mean, that is until the tariffs kind of, you know, took hold. Like, for instance, this batch of parts that's enough to do, should be enough to do like 10 hands. It was a little over $5,000 for the parts, just for the fingers. Now, this is just for the fingers. But I had a $1,600 tariff to go with it, and that was last year that I bought the parts. You know, if I were to buy the parts right now, I'd have like a $7,000 tariff. Which, you know, that would suck. You know, you end up paying, say, $5,000 for your parts, and then you end up spending $7,000 on your tariff. So, but I can't really find anybody in the U.S. domestically that is printing mag aluminum and, you know, wants to be doing it in the quantities that I'm working with. You know, because I'm still doing kind of, you know, onesie-twosie type thing. You know, and most everybody I talk to that's doing the 3D metal printing. Okay, so it's classified as MgSiAl, and that's its chemical makeup. So it's magnesium, silicon, aluminum, and it's stronger than like 7075 T6, and it's SLS 3D printed, so selective laser sintering, but it's got the weight of aluminum. So it's got the right weight when it's all assembled, but it's got really good strength. And, you know, it doesn't have a heat affected zone that you do, say, if you were to print them out of titanium. I mean, you know, I could just print all of these components out of titanium, but then when you're threading them with, you know, 172 and 256, so most everybody that's printing in the U.S. is printing Inconel, Monel, and your stainlesses or your tool steels. You know, the part of the issue with the mag aluminum is it catches fire. You know, because magnesium is an oxidizer. It's an oxidizer metal. So I briefly toyed with the idea of doing titanium, and the cost was just stupid. So like this medial, I can stick on the 4th axis on the milling machine, and I can make it in about, the cycle's about 25 minutes to make this from a piece of 1-inch round stock. Or I can have this 3D printed out of mag aluminum for like $7. Or if I did it out of titanium, this is $100. Which, you know, that took the ideas of having titanium fingers and just right out the window. Yeah, okay, so, but you can't do the silicone bronze because then you can't Cerakote them. So Cerakote doesn't like any of the yellow metals. It doesn't like any of the brass. And part of what I'm wanting to do is do a product called Microslick on the pins, and then just do regular Cerakote on the rest of the parts. We're down to 4 more. Then we can go over to the milling machine. So I wouldn't do that. I know a guy that he swapped his big toe for his thumb, and I think he swapped his second or third toe for opposition to his thumb. You know, for me, it wouldn't be a good... So I don't know if you remember, but like the 157, 158 hands, they were aluminum and brass and stainless. They were pretty bougie. I mean, they were steampunk looking. A couple of them I even did with big gears and chains and differentials, and they were all kinds of steampunk. Well, and then you got to do the welding goggles too, if you're going to do that. Top hat with the gears, you know, gear on the top, and then the welding goggles with the polarized lenses. And then the chain with the pocket watch. You know, you got to do that. And then you need a cane. And, you know, then it's double-breasted vest. Yep. At one of the Maker Fair, I think it was Bay Area a couple years ago, there was a guy that had an auto-tipping top hat. You know, he just had it hooked up with an Arduino and a servo motor with a couple scissor mechanisms. Oh my gosh. Oh gosh, no, steampunk is not viable. No, it is. It's all look. Although, I don't know what. This was probably a year and a half ago, 2 years ago. I had someone debate the nomenclature of steampunk for what I'm doing, and it's just, you know, it's like, well, none of your stuff is steam powered, so, you know, you can't call it steampunk. And I'm like, wow, you should get out of your basement if you're really debating, you know, whether this is steampunk or anything. Hey, this is my favorite distal right here, because it's the last one. Oh no, I mean, hey, I have brass chain connectors. See that? Brass chain connectors for my cross links. I even occasionally do brass rollers. Although the brass rollers don't seem to last. They don't last hardly anything under load. And I'm using like 454 Oilite, you know, oil impregnated. And they don't last very long. I mean, I say that. I'll get probably 5 months, maybe 6 months out of brass rollers. I mean, if you remember way back, I was making brass screws on the turret lathe. I did a whole video series on that, where I was doing automatic screws. So close. Oh, just a little bit grassy. There we go. Okay, that is my favorite distal right there. So, a whole bag of distals. Yay. Now I got to drill the holes. And then while I'm doing that, I'm going to drill and separate out the distal links. I have a whole bag of those too. Brass. Brass, I usually just order it in as bearing stock. So, like for this winder, I use 1/2-inch bearing stock and then 1-inch bearing stock. And then for the locking sprocket, that has to be out of aluminum because it's got sprocket teeth that are milled into it. I mean, the thing is, none of this stuff is actually sized to where you could really cast it with any efficiency. I mean, you could cast it into rods and then, machine it from there. But, the thing is, for the cost of what bearing bronze in, say, like a 1/2-inch or 5/8 by 13-inch rod, it really isn't that expensive. Well, thank you, sir. Yes, it has been a while since I've seen your name come across in the chat. So for these, I ended up ganging these together, and these were the same price to have 1 made versus having 5 made. Because you run into the part minimum cost. All right, let's get the rotophase set up and get cameras over on the milling machine. And then get all of that set up. All right, I think I got the right drill bit even set up in the machine. Let's see. Hold up, let me go get my phone holder. Be right back. clean off some room. I'll go put some my collets back. Let's get a light going. Close the back door. So this is my fancy, holds both of my phones and clamps onto most stuff. So I will boop it to there, and then boop that, and then boop that. So let's see which phone you are. You are not that phone. You are that phone. And then this phone goes over here. That. Be a little bit more like that. And if you go like this, then you guys can see what I'm doing. How about that? No, milling machine. Milling machine, we gotta pop the holes into them, into all those parts. And then same thing for all of these distal links. So I got 100 distal links that are 100 distals. And then, I don't know, 100 something. So these got to be 94 thousandths. $75. Let's see. 75, 85, 91. And then this is my pin stock that I'm using. Okay, so that is 91, 2, 3, 4. So I need just a little bit bigger drill bit. I need like a 2 thousandths larger drill bit. Let's see what these are. They're number 43, but they have to be so these are smaller. You know what? I'm gonna drill a couple and see if with the wiggle, if with the wiggle you get enough play in there for the pin. Oh, gotta be faster than that. Nope, not the right size. But I'm gonna drill all these and then upsize them. So I'll end up doing these twice. And the reason for doing these holes twice is because these holes, as they come out of the SLS machine, they aren't really round. So what I'm doing is, with the first drill, I'm getting them kind of round, and for the second one, I'm actually reaming them to size. Lost one. Well, hello. Hello, mysterious person from Russia. Oh, cool. I have not been to there. It's got to be first thing in the morning for you guys right now. Alright, now I gotta get a drill bit that is 0.0955. Which I think is a number 41 drill bit. No. That is going to be too big. Okay. Well, not out of that set. All right, 0955. What up? What up, Janie and Gemma, the kitty from Canada? Oh, that's awesome. Where is my four-way key? I guess I don't need it. Honestly, you wouldn't be able to do it. Unless you had casts of their residual limb. Because so much of this isn't so much the mechanics itself, but it's the fit on the residual limb. So, you could order, say like the entire mechanics of it, but you'd have to work with them in order to get the socket to be just right. Because if the socket doesn't fit, they're not going to wear the device. Actually, would you guys prefer to see me drilling the holes or watch me? Okay, so this is the pin stock that I'm using. Yeah, sorry, it's more than just measurements. It's actually a thing of how it feels. That doesn't fit for nothing. I need it to be like half a thousandth bigger. Not that one. Oh yeah, no, and the thing is, uh, it's so like if I get fat, say I put on like 5, 10 pounds, my prosthetic doesn't fit the same way that it does, when I'm at say like, 190. If I weigh 190 pounds, prosthetic fits great. If I get up to 200, it starts being really tight. So, I mean, that's something to take in consideration, too. And you wouldn't think that 10 pounds would make that much difference. But let me tell you, it does. It makes all the difference in the world. Okay, so this one is 2.5 thousandths bigger. So I'm going to set that one aside. I mean, it would work, but it's bigger than what I really want for the fit. But might end up doing that. Okay, I think we're going to go with oh, you totally are. No, and the thing is, once you adopt a device to be, this is, this is my device, this is what I'm using as a daily driver. I mean, the idea is to have it become, actually what you would consider to be part of your body. That's when you have a really good device. When you're like, to where when you aren't thinking about using it, when you're, when you're doing stuff with it. I mean, it's like every so often I'll catch myself, picking something up, and I'm not even thinking about how I'm picking something up with the device. And, that's when that you have it just dialed in. And that's awesome when that happens. Okay, we're going to go with this one. And then we'll see how that actually fits on the pin. Well, that didn't drill for nothing. It fits about right, but it didn't drill at all. That needs to be sharpened so bad. Yep. Okay, I'm going to save this one off for being sharpened. I think that's a number 41, in case anybody's taking notes. Okay, I'm actually going to sharpen up this one. I'll be right back. Okay. Let's see how this is doing. See if this drill's any better. Okay, that fits pretty okay. Alright, so all those are all drilled now. I gotta just take a swipe off with a file just to get rid of the burr from the burr from the drill. So, and then those will be done. So next we'll be doing the distal links. I actually have to cut those apart. Those are in strings of, I think, 5. Yeah, they're in strings of 5. And then I'll drill those. So cut them apart and then drill them. The next couple of days I got to start making pins, which I do on the drill and cutter machine right next to me. But they have a little groove in them for the 3mm circlip. So that actually becomes, you know, a little bit of a setup. Oh my gosh. Hopefully the prints for the milling machine vice jaws turn out good, and the the rough parts end up fitting. What I'm doing for that is a front and a rear jaw that just bolts into the vise, and then it'll hold either, like I'm doing one for the metacarpal bases, and you just put it in vertically, and then you'll go and do the pocket. And then the one that I'm doing for the proximal ones, it's actually set up for 3 proximals at a time. Like a pinky, a middle, and an index or ring. So those will end up fitting pretty good, I think. So that'll be pretty awesome. Boy, chat's being off quiet. You guys just like the ASMR of me filing parts and drilling parts. Oh, last one. Okay, there's a bag of distals. Okay, well, I'm gonna call this live. Maybe do it again tomorrow. Everybody that's been hanging out, thanks for watching. I really appreciate all the support that you guys are giving me. Yeah, check in again tomorrow. Thanks for watching.